Here's the solution to homework set number 11 for ECE 341. Now in the first problem, we're playing a game of, well, some game, and two teams are playing. A's got a 45% chance of winning, 15% chance of a tie, 40% chance that B wins. If you have to win by 2 games, determine the probability that A's win the match after K games for K equals 0 to 10. Well, one way to do this is to first set up the state transition matrix. That's right here. If I start out at even, then 15% chance I'm going to stay at even, 45% chance A is going to win, I'll go up a game, 40% chance A loses, I go down a game. If I'm at +1 game, this column, +1, 45% chance will go +1, tie, down 1. If I'm at +2, the match is over. And likewise, if I'm at -1, -2, at -2, the match is over, B wins. Now note when you do this, I've got 2 absorbing states. The first column, second column is a 1, 0, 0, 0, 0. That means that's an absorbing state. Once again, in that state, I'm stuck. And also note that the other columns, the columns have to add to 1. That's for all probability. All probabilities have to add to 1. That's a quick way to check for errors. So once I get that matrix, I can throw it in MATLAB. My initial game is I'm starting out at even. And then I can find what's the probability that A wins after 0 games. That's A to the 0 times x0. 1 game, 2 games, 3 games, 4 games. Just take that A matrix to the 4th power times what I want to look at, the first state, that A won, times my initial condition, and I get the probabilities. That's one way to solve this Markov chain. Problem 2 is solve a different way. Solve using z-transforms. Now, for those of you that don't have the control system toolbox, what you can do is MATLAB has an online and the MATLAB Online does have the Control Systems Toolbox. So if you start using MATLAB Online, you'll have to log in. When you log in, you'll need to use your NDSU email address. And then once you get in, you can open up MATLAB Online. And here, you've got the Control System Toolbox. Eventually. So if you input your system A, input your system A, your x0 is your initial condition. I'm going to start out at even. C is what I want to look at. I want to see what's the chance that A wins. There. G is state space of A, x0, C, 0, discrete time. Now I can say, what is the transfer function? Multiply by z, I get the z-transform for y. So again, if you don't have the Control System Toolbox on your home version of MATLAB, MATLAB Online has it, or you can reinstall it with the Control System Toolbox. So anyway, once you get the system put into MATLAB, I can input the system, find the transfer function, multiply by z to get the z-transform for probability that A wins. Now take the inverse z-transform. Again, I'm going to do partial fraction expansion. Plug in z equals 1, analyze, I get 0.5568. Plug in 0.75, cover this up, analyze, I get minus 0.675, and so on. Take the inverse z-transform, multiply through by z, then take the inverse Z transform, I get each of these terms. 0.5586 times 1 to the k minus 0.6750 times 0.75 to the k plus 0.1164 times minus 0.45 to the k. And if I analyze that and calculate p of k, that's exactly the same answer I got in problem 1. Second way to solve. Using that, I can do something like, what's the probability that A is going to win a game of tennis? Now in tennis, you have to win by 4 points and be up by 2. So there's a couple ways that player A can win. I could be up 3-0, then A wins. I could be up 3-1, then A wins. I could be up 3-2, then win. Or I could be tied 3-3 and then go through Markov chain, best of 2 series. That's the conditional probability. So the probability that A wins given it's up 3-0 is 0.55. The probability of being up 3-0 is a binomial distribution. 3 games choose 3, 0.55 cubed, 0.45 to 0, 9% chance. The probability of winning after being up 3-1. Well, the probability of winning is 0.55. Probability of being up 3-1 is 4 games choose 3, 0.55 cubed, 0.45 binomial. Multiply the two together, I get 16%. Probability that A wins after being up 3-2 is 0.55 chance of winning. So that's 0.55. Probability of being up 3-2 is, oops, this one's 0.55. Binomial, 5 games choose 3, 33%. And the last one is the probability of being tied 3-3 is 30% chance. Probability of winning after being tied is a Markov chain. So here's your state transition matrix. 55% chance of winning, 45% chance of losing. Take it to the 100th power. A's got a 59% chance of winning, given that you start out at 3-3. Adding that in, that'd be 0.55. That's always 0.55 times 0.5990, 18% chance. Add them all up, the total probability that A wins is 62% chance. So that is homework set number 11 for ECE 341.